All right, hello and welcome. And I'm back with one more ISI video, an objective problem that was asked in 2026. And I'd like to wrap this video up in a couple of minutes, and I'm hoping that I'll be able to do it. So let's dive into the problem. The problem says that let p of x be a polynomial with integer coefficients of degree greater than or equal to 5. Suppose p of 0 and p of 1 are both odd integers, then you have to find out the cardinality. So this means cardinality of all x belonging to integers such that p of x is 0. So fundamentally, they're asking you to find the total number of integer roots of p of x. And p of x is a polynomial with integer coefficients. And it's given that p of 0 and p of 1 are both odds. So, well, I'm going to claim that there is no integer 0 of p of x. And the proof goes like this, that say that a is in fact an integer such that p of a is 0. So a is an integer. So this is z, by the way. And p of a is 0. And I'm going to borrow, in fact, I'm going to draw from the ISI subjective paper where we have proved that if a is an integer and if m and n are integers and p is a polynomial with integral coefficients, then pm minus pn is divisible by m minus n. So m minus n divides pm minus pn if m and n are integers and p is a polynomial with integer coefficients, right? So we can say that a minus 0 divides p of a minus p of 0, and p of a is 0, which means that a minus 0 divides minus p of 0. Let's get away with this. So a divides minus p of 0, which means a divides p of 0. And since p of 0 is odd, it means that a is odd, right? And similarly, we can argue that a minus 1 will divide p of a minus p of 1, and which is equal to minus p of 1 because p of 0 is 0. And if you remember, p of 1 is also odd, which means a minus 1 is also odd, which is quite odd if you look at these two statements, which says that a is odd, and then it says that a minus 1 is odd. So both of them can't be simultaneously true, and therefore such an integer a can't exist, and therefore the claim is proved, and which means that the cardinality of this set is 0. And we are done.